To solve a logarithmic equation, ultimately I want to get rid of the logs so that I can solve for x. So when I have two separate logs, I want to first use law number 1 to change this sum into a product of just one logarithm. So now that I have just one logarithm, I can change from log form to exponential form by taking the base of the logarithm and moving it to the other side of the equation by making it a base, which will push the right side of the equation up into the exponent. So I'm left with x times x minus 2 is equal to 2 to the 3. But 2 times 2 times 2 is just the number 8. So now when I expand out the brackets, I get x times x, which is x squared, and 2 times x, which is 2x. So if I move everything over to one side, I get 8x squared minus 2x minus 8 equals 0. So now I can factor using the Chinese method or the quadratic formula, or your favorite method, finding two numbers that multiply to 8 and add to negative 2. So 4 needs to be negative, 2 needs to be positive. So this gives me two possible answers for x. Either x is 2 or x is 4. Now this is where everybody forgets that there's one more step to this problem. We can't just take these answers and circle them both. We always have to go back and check, because sometimes we'll get answers that don't actually work. So we have to go back to the original equation and plug in the values, because we're not allowed to take log of a negative number. So if we have a negative sign, we're going to plug in, instead of x, we'll plug in negative 2. And if we have a negative sign inside of a log, then we've got a problem. So here we've got log base 2 of negative 2 and log base 2 of negative 4. Okay, but log base 2 of negative 2 does not exist. Neither does log base 2 of negative 4. So it turns out that x equals negative 2 is not actually an answer to the original problem. So we should also check with 4. So we're going to plug in 4 instead of the x's. We get log base 2 of 4 plus log base 2 of 4 minus 2. So this gives us log base 2 of 4 and log base 2 of 2. So as long as the inside of our logs are positive, then that solution works. So x equals 4 is the only answer to this problem, not x equals negative 2. Now let's go to the graphing calculator and check it out. So to check your answer, we can go back to the original question and graph it. We're going to graph both sides and see where those two graphs cross. So we'll go to the y equals. We'll put in, since we can't put in log base 2, we're going to have to use the change of base formula. To change of bases, we can do log of the argument divided by log of the base. And again, log of x minus 2 divided by log of 2. Okay, the right side of the equation will be the second graph. And when we graph it, there's our log, and there's 3. We want to find out where those two graphs cross. We're going to go second, trace, choose number 5, intersection, and then we'll use our arrows to get onto the curve. There we go. The first curve is a log, the second curve is a line. Doesn't matter where you guess. The answer is x equals 4. So you can see from this graph that the graph doesn't cross anywhere at negative 2. There's only one crossing place, which is 4. This is another way to check your answer and make sure that you got it right.